Well, hey there, and welcome to another evening of homework. Tonight is Wednesday's homework is going to be on the Go Math, page 199, even numbers 2, 4, 6, 8, 10. And so let's take a look at problem number 2. On problem number 2, it was already showing you fraction strips. I'm going to use my one whole as a benchmark because that's that goal so that we can see it. I'm looking at my 2/3, and so I'm needing to place my 1/3 plus my 2/3 that will represent my fraction. And so how many 1/4 will I need to put down? You're right. Here's 1/4, here's 2/4, and here is 3/4. But oh my gosh, we have a problem here. It's running off on our page and it's longer than my whole. So immediately this tells me it's going to be what type of fraction? Yep, you're absolutely right. It's a mixed fraction because I'm already going to have my one whole, and then whatever is left over will be my fraction added with my one whole, making a mixed number. Okay, so now let's take a look. Are there any fractions that I have, because you took your fraction strips home today, are there any fractions that you have that will equally fit in the 1/3 as well as the 1/4? For instance, I can take my 1/5. Can I fit 1/5 equally into a third? No, not at all. This won't equally fit. So 2/5 is not equivalent to 1/3. So I'm going to remove that. Let me take my 1/6. That's 1/6 and 2/6. Absolutely. 2/6 is equivalent to 1/3. But now let's look at this. Is it also equivalent to 1/4? That's 1/6. And I need to look for my other 6. See if I have one in this pouch here. And I have my other one. So is 2/6 equivalent to 1/4? No, not at all. We can visually see that that is not going to work. So we know that we're not going to be able to have a new denominator of 6. So I can try my 8. I know that 2/8, as we talked about today in class, is equivalent to 1/4. But is 2/8 equivalent to 1/3 or even 3/8? No, because it goes over a bit. So we know that's not going to work. So now you're going to move on up until you can find the fraction that's going to fit into the 1/3 as well as to the 1/4 divided equally. So remember we were talking about taking our denominators and using them as an array. I know that 3 times 4 equals 12. So I'm going to try my 12ths. And I'm looking here and I have 4/12 is equivalent to 1/3. So I'm going to have my 4/12. Then I know that if I scooted this over, or I'll just add my additional 1. Not going to have enough of the 12ths, that's for sure. Because remember, it's going to be going past my one whole benchmark. So here, how many 12ths do I have that's going to be equivalent to 2/3? They're even denominators. They're the same denominators. So 8/12. 1, 2, 3, 4, 5, 6, 7. 8/12 is equal to 2/3. So I'm going to pull this 8/12 down. Let me scoot that up so that you can see that. And now I'm going to take my 12s, and how many 12s will equally fit into my 4s? So that's 1, 2, 3. So if I have, so now I know there's 3 12s that's equivalent to 1/4. Then how many 12s would be equivalent to 3/4? Well, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 twelfths. I know that 9 twelfths is equivalent to 3/4. Now I'm able to add those up. Now I can show you here by extending it out. But again, I won't be able to extend it out as far because I won't have enough 12s, because there's only how many 12s in a 12? Absolutely right. Only 12 twelfths in a 12. So here's my 12, and then I still have more to go. How many would I have left over? I'm going to just pull from this back end so that it can show you. Actually, I'm pulling from another. That way you can see it. I'm going to be combining. Again, I said that there was going to be 3 twelfths that are equal to 1/4. Here I have 2 more that are blank. And I used another one. You won't have enough, but I broke into another set to get more 12s. So if I wanted to add these up, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 twelfths, which equals 1 whole. Where was I at? 3, 4, 8, 11, 12, 13, 12. Then I have 3, 4, 5 that are left over, which will equal to 1 and 5 twelfths. If I counted them all together, again it's 4 plus 4 is 8 twelfths, plus 3, 6, 9 twelfths. It will give me a total of 17 twelfths. And we were talking about that we could divide because, again, this is called an improper fraction. And as one of the students mentioned today, we take our denominator and divide that into our numerator. So we say that 12 goes into 17 how many times? Let me bring that down here. So I'm going to have one group of 12. I subtract that out using standard algorithm of division. And 7 minus 2 equals 5. This is my new numerator. Here's my whole number. And again, my denominator never ever changes. And so I have 1 whole and 5 twelfths. Okay? Now let's take a look at number 2. I'm going to erase this here. Just take off my tiles. And this is going to, my problem here is the 2/3 plus my 3/4. I know that 2/3, the equivalent is 8 twelfths. And the equivalent fraction of 3/4 is 9 twelfths. And I know that my denominator will never change, so I'm moving this over, and this equals 17 twelfths. To simplify it, in its lowest term will be my 1 and 5 twelfths. To check my work, I'm going to take my denominator, multiply it by my whole number, put that in parentheses, and then add my numerator. So it'll look like 12 times 1, and that's 12 plus 5, and that equals 17. My denominator never changes, and that's what I originally started off with. So my work is correct. Okay, there we go. All right, now let's take a look at number 2. Number 4. Number 4's problem is 5/6 plus 1/2. again, I'm going to use my 1 as a benchmark. And I'm going to get my 5, 6. And how close is that to a whole? I'm only short 1, 6 because 6, 6 equals 1 whole. Very good. So that's 1, 2, 3, 4, and 5. Again, what do you notice about this? If I added my 1/2 to it, it's going to go beyond my 1 whole. So now I know that it's going to be a mixed number. Again, it's going to be a whole number plus a fraction. Now, they're even numbers, right? So we can have those cut in half. Well, if I can slice those in half, what then would I be able to multiply by 2 to get a 6? We said it's a third. We could do the thirds. But will the thirds go here? No, not at all. However, can I continue my 6? That's 1. Since you only have 1 back, I'm going to actually borrow from this end and take it over here. Still knowing that I have this here. I'm going to kind of draw that on my paper. 1, 6, and 1, 6. So now I have a total of 1, 2, 3, 4, 5, 6, 7, 8. I have 8, 6. I had my 5, 6 plus my 1/2 is equivalent to 3, 6 equals 8, 6. And look at this. I know that my 6, 6 equals a whole. So if I subtract, and this is another way that you can do it, you have 6, 6 minus the 8, 6 minus 6, 6, because that's 1 whole. Remember, this equals, it's equivalent to 1 whole. 8 minus 6 is 2, 6. Isn't that what I have left over here? 1, 2, 6. So my answer is going to be 1 and 2, 6. Again, even numbers. So when we're going to be reducing it to its simplest form, I can take my 1. What is half of 2? So I can divide that by 2. I can always take halves from my 2. 2 divided by 2 equals 1. 6 divided by 2 equals, that's right, 3. And it's 1 and 1/3. So I know that 1 and 2, 6 is also equal to 1 and 1/3. And we can actually prove that, because if I have my 1/3, can I put 2 6 into it? Sorry about that. Yep, it absolutely works. Trying to see what that goes. And so for this one, this equation, I will keep my 5, 6 the same, and it'll be the 5, 6 plus, and then what did we say? 3, 6 is equivalent to 1/2. 5 plus 3 over 6, because my denominators are the same, equals 8 over 6. Again, we can take out that 1 whole, or you can divide into 6 divided, goes into 8 one time with a remainder of 2. It's 1 and 2, 6. Or if you are weak at the division part, again, taking out 1 whole.